Example 7, find function values with a calculator. You're going to recognize that this is a calculator question because the numbers are going to look messed up. All right, if the numbers don't look like anything you've seen in the chart, multiples of 30 or multiples of 45, it's probably going to be a calculator question. Trick is, though, on part A, they've got 49 degrees and 12 minutes. So we have to do what we did on the last quiz. All right, we want to convert it back to decimal degrees. So we can just divide by 60 there, just like we did on that last section, and figure out that that's really 49.2 degrees. So if I convert to decimal degrees, this is an easy question because I can just type that straight into my calculator. I want sine 49.2. Make sure you are in degrees. Okay, so make sure you're in degrees. And then you get 0.7570 approximately. 0.7570. I'd say 4 decimal places are about right. Watch Math Excel because they'll tell you exactly what to do. Now, secant, you're going to notice you don't have a secant button on your calculator. All right, so you have to remember the fact that secant is the reciprocal of cosine. So what I'm going to do is I'm just going to change this problem to 1 over cosine 97.977 degrees and type it in like that. 1 over cosine 97.977 negative 7.2059. So then what do you think we're going to do about part C when it says 1 over cotangent? Yeah, just change that to tangent. We know 1 over cotangent is equal to tangent. They are reciprocals, so it's tangent 51.4283 degrees. .2539. And then the last one, part D, this is the easiest one because I don't have to do any kind of converting or anything. I just type it in. That negative will go in there, sine negative 246.9135. Number 8, use a calculator to find an angle theta in the interval 0 to 90 degrees that satisfies each condition. All right. So one thing to look at is this interval that says from 0 to 90. Your answer is going to have to end up between 0 and 90. That's going to be really, really important in some of the problems here. Maybe not this one so much, but later it might make you go between 0 and 360 or 0 and 180 or something like that other than 0 to 90. But just make sure your answer falls within that interval. Okay, now, people get confused by part A because it looks weird, but I want you to remember how we always solve equations, okay? So don't write this down, but if I gave you 4x plus 2 equals 26. All right, you've solved equations like that a million times in your life, and every single time what you're trying to do is undo the operations. You'd subtract the 2 to get rid of the plus 2, and you would divide by 4 to get rid of the times 4. All you're doing, you guys are on autopilot. Whoops, that's 24, right? So divide, and then you get 6. You've done that a million times. All you're trying to do is undo the math, undo the operations that are on the variable, okay? And this can be done pretty much anytime you only see one variable. If you've got more complicated equations, we have to do more complicated techniques. But right here, when you only have one variable, you're always trying to undo whatever it is. Think about if you had a squared, you would undo that by taking a square root, right? Plus or minus, or anything like that. So the thing is here, you have an equation with only one variable. So we want to get rid of the math that's done on that variable. in this case, it's not plus 2, and it's not times 4, and it's not squared. It's the sine function, okay? And what you're doing to get rid of all of these things is the inverse operation. So the inverse of that plus 2, the inverse operation was to subtract 2, and the inverse of times 4 was divide by 4, and the inverse of squaring a function is a square root of a function. You're always just doing an inverse to cancel it out, and so that's what we're going to do here, okay? Talk, talk, talk. All we're doing to get rid of a sine is an inverse sine. We are going to take an inverse sine of both sides, and so that's going to knock out and give me my variable by itself, just like I want. Sine will equal, actually it's approximate, but whatever, inverse sine of that big long string of numbers, 0.967. Oh my gosh. My computer is like on a 3-second delay right now. Come on. Well, let's just do this. Let's just go to the calculator. It's going to be an inverse sine of that string of numbers, 0.967091705. We get about 75.4, okay? So your theta is about 75.4 degrees. Now notice that does fit within the interval that we were expecting. Our answer was supposed to be in between 0 and 90, and that's what we got. I'm going to try to fill this back in. 96770911705. We took the inverse sine of that. All right, part B, inverse secant. We would want to do an inverse secant, but the problem is we know we don't have an inverse secant button on our calculator, okay? So you have to go through cosine. And so there's a couple of different ways to do it. I'll show you the long way first. The long way is just to understand that secant is 1 over cosine. Oh, this computer's struggling. Okay. So we would have 1 over cosine theta equals 1.0545829. All right, but that's a little bit tricky because your variable is on the bottom. You can't just do an inverse cosine here because that variable is on the bottom. And so what you would want to do is do a reciprocal. Okay, you would want to flip that over. Okay, imagine if I said 1 over x equals 4. That's kind of hard to solve, so you would flip it over and say x equals 1/4. Okay, we're doing a reciprocal. So I can do a reciprocal of both sides and say cosine theta equals 1 over 1.0545829. Okay, and now I can do my inverse cosine. Okay, but notice, if you really know what you're doing, you're going to skip that red step completely because I just took the reciprocal of both sides. I went from the original step to the green step, and I just knew, well, I'm just going to take the reciprocal of both sides. Secant and cosine are reciprocals, so skip the red if you can. And then we're going to do an inverse cosine on both sides to get that variable by itself. So on the calculator, I'm going to do an inverse cosine of 1 over 1.054582. What am I missing? 9. And I get about 18.51. Theta is about 18.51 degrees. Again, just be careful, make sure you know and understand. You're looking for a number, you're looking for an angle that's in between 0 and 90. Sure enough, we got it, and that's it. Example 9, find all values of theta if theta is in the interval from 0 to 360. All right, that's going to be kind of important that we do. This is a really, really important question. right? Probably the second most important question of the entire year. This question will come back over and over again. So this lesson, this section right here is really important. We want cosine theta equals negative square root of 2 over 2. We're trying to find the angle. We're trying to find the angle or angles, okay? And so another way of looking at this question is if you're trying to find whatever this angle is that gives me negative square root of 2 over 2. Okay, so if you look at the chart, you can still look at the chart. Where is it? Here, okay, and you can look at cosine, and you can look at square root of 2 over 2, and it's kind of like you're using the chart backwards to get to this 45, all right? That 45 is a reference angle, okay? And so, let's see where we are. It's going to have something to do with 45, okay? It's a 45-degree reference angle. But what we have to do is pay attention to this negative. And so I'm going to write it down like this. I'm going to say it's 45 degrees where cosine is negative. Because we have to have a negative, it's not a negative angle so much, but a negative x value is what we're looking at. So if you look at your quadrants, think about where cosine is negative. Where is cosine negative? Not quadrant 1, 2, and 3, because we're talking about an x number. Remember, cosine is x over r. We're basically talking about an x number, and we would know that cosine is going to be negative in quadrants 2 and 3. So essentially what happens is this. You want to think about a 45-degree reference angle in that second quadrant. Okay? So think about what that angle would be. Basically, you're going to do 180 minus 45, right? This is 180. So 180 minus 45 is 135. That's one of our answers. There are two answers. One for the third quadrant, or one for the second, one for the third. If you look at the other answer, okay, the other answer is going to be a 45-degree reference angle in the third quadrant. And so again, you have to think about what that angle is going to be. It's 180 plus 45 this time is 225. So we have two answers. 135 and 225. You should be able to check your answers and say something like this. If you did cosine 135, or if you did cosine 225, you get that decimal number, which should be hopefully negative square root of 2 over 2. All right. So sure enough, we're looking at the angle. We got the angle that led us to negative square root of 2 over 2. Now, I talked about that for like almost 4 minutes, but once you know what you're doing, this is a really quick problem. If you know what you're doing, this is probably like a 5-second question. Okay? So we look at this one. Sine theta equals square root of 3 over 2. So if you go back to that chart, okay, go back to that chart, what angle does that point us to in the chart? 60 degrees. Okay, go back to the chart if you need to, but that's a 60-degree reference angle. That's going to be a 60-degree reference, and since this is a positive number, we're looking at a 60 positive. Okay, so how are you going to think about this is you want to think about where is sine positive. Well, we know sine is positive in the first and second quadrants. So you need a 60-degree reference in the first and second quadrants. Okay. So the first quadrant is pretty easy because it always just is what it is. I think my computer's falling back again behind. 60 degrees is one of your answers. And then you've got another one. 60 degrees before 180 is 120. Two answers, 60 and 120. Example 9, it's really pretty much the same thing. Okay, pay attention to the interval. We need answers between 0 and 360, but it says tangent theta equals -1. So let's go back to the chart and look at where tangent is equal to 1. There's no -1 on this chart. The tangent is equal to 1 at 45 degrees. So it's another 45-degree reference angle. So what I'm saying here is you should quickly, from the chart, understand that it's a 45-degree reference where tangent is negative. All right? So quickly, what you would do is you would say, all right, where is tangent going to be negative? All students take calculus. I know tangent is positive in the first and third, so it must be negative in the second and fourth. Okay? So we're talking about a 45-degree reference angle in the second and the fourth. So you'd have to figure out what that means. 45 degrees before the x-axis is 45 degrees before 180. Think about 180 minus 45, and that'll get you 135. And then 45 before you get all the way around to 360. So that's 360 minus 45 is 315. Once you get used to doing these, you're going to see the same numbers pop up over and over again. If you need to use a calculator for that, for now, you did 180 minus 45, and I did 360 minus 45. But you're going to get to where that you're doing those calculations in your sleep. Next one, cosecant theta equals square root of 2. So if you went back to your chart, let's see, where is that? What was it, cosecant? Or was it secant? Cosecant? So we're looking cosecant square root of 2. Oh, great, that's 45 again. So that's another 45, right? So we're saying 45 positive, since that is a positive number. Cosecant goes with sine, and so we're looking at where sine is positive, and we would know that sine or cosecant are positive in the first and second quadrants. So we have a 45-degree reference angle in the first and second quadrants. First quadrant should be easy, because it is what it is, 45 degrees. Second quadrant, you would just take 180 minus, you're going to get 135 like we did before. Example 10, the force F in pounds when an automobile travels up or down a hill on a highway is called grade resistance and is modeled by the equation F equals W sine theta. All right. W is the weight of the car, and theta is the angle of the hill, I guess. You should notice that when that angle is positive, we're going uphill, and when that angle is negative, we're going downhill. Part A, calculate F to the nearest 10 pounds for a 2,500-pound car traveling an uphill grade with theta equals 2.5. All this is telling you what to round to, so you can ignore that for a second. Let's just look at the formula. Force equals the weight of the car times sine of the angle. This is just a calculator question. Make sure you're in degrees. You get 109.05. Since they told me to round to the nearest 10, I'm going to call that 110 pounds. Part B is the same thing, really. It's just going downhill now. It's a different weight, 5,000 pounds, and and it's going downhill this time, but it's just a plug and chug question. Negative 531.3. Or rounding off, that's negative 530 pounds. All right, part C, I think part C really brings it into focus of what we're finding. Remember, F is the force that's acting on that car. But this one's kind of weird because it says for theta equals 0 and for theta equals 90. You've got two different problems. They don't give you the weight of the car, but it turns out that it doesn't matter. Anybody know what sine 0 is? Sine 0 is 0. So if you take 0 degree angle, weight times 0, bless you, is going to be 0 pounds of force. So if you think about a picture of this, I think that makes it clear what's happening. You've got a car sitting at at an angle of 0 degrees. There's 0 pounds of force acting on that car. All right. So the other one is 90 degrees. Force equals weight of the car times sine 90 degrees. Anybody know what sine 90 is? That's 1. So force is going to equal whatever the weight of the car is. So if you look at a picture of this, it's a 90 degree angle. So think about what that car is doing on a 90 degree angle. Yeah, of course, that makes sense. The entire weight of the car is pulling down on that. So that's the force acting on that car. That's what this is talking about.